Changing gears a little bit, I'm actually going to talk about a pilot course that I taught at the University of California in Santa Cruz. I'm now an assistant professor at the University of Hawaii in Manoa. And I'm going to be redoing this course there now that I have a stable teaching position and can do it multiple times and can get lots of statistical data. But this talk is really about the pilot course. I had the opportunity of working with the NSF-funded Center for Informal Learning in Schools. As a science graduate student, you're not taught to teach. You're not. You're taught to be a scientist. And as a science grad student, I thought that was horrible. I wanted to learn how to be a good educator as well. I wanted to learn how to teach my students what I loved. I wanted to learn how to communicate those ideas in a way that was memorable, in a way that would excite them and make them maybe switch majors and come to my department. So it was a little selfish. And I had the opportunity to work with the writing department. Now, I was an earth and planetary science person, so you don't have a lot of earth and planetary sciences teaching writing. No, it's not typically programs that go together. And so one of the benefits of the Santa Cruz writing program is that they didn't have enough teachers. They didn't have enough people to teach enough of the freshmen. They wanted to have very small courses, limited number of students, lots of student-teacher interactions. And so they encouraged graduate students from all divisions, math, physics, earth science, sociology, psychology, to teach writing courses based on different topics. So this gave the students the opportunity to learn about writing in a variety of different contexts. Okay. So the motivation for me for teaching a writing class on climate change was really because the media representations of scientists are confusing. They're confusing for students who don't have a solid background in the science content. They're confusing because what they see in movies and they see on TV and they see on the internet can be completely different than what their families and their parents and their communities say. Okay, so that's hard for students to be able to look at all these different sources and figure out which one's right. Okay, and so the accessibility of the accurate science information is typically science courses, right? And not every person's a science major. So how do you alleviate that problem? How do you get non-science majors access to accurate, consistent scientific information, right? Some people consciously avoid science classes, right? They will not take them if they can avoid it. They'll take rocks for jocks. That's what we call Geology 101. You know, they'll take the easiest class possible, which is not necessarily something that will help them evaluate science information in the media or in their communities. Okay. And of course, there's deliberate disinformation, like some of these fun little cartoons here. You know, global warming's a hoax. You know, if they see these things, what impact does that have on their perception of what the science, which one's correct, right? So the class itself was called Writing 1/2. It is now called Writing 2. It was in the process of being transitioned. It was a winter course. It was 10 weeks long, so it's a quarter system class. So I only had the students for 30 classes, 3 days a week, 8 a.m. 8 a.m., yes. So they were either there voluntarily and were morning people or had to take it to graduate. Okay, so it was an interesting group of students who really wanted to be there. So that was a plus for me. It wasn't an evening class that they, you know, could squeeze in between dinner and doing their homework. So this class was necessary to graduate. You had to take Writing 1/2 to finish your degree. Okay, so this is a great opportunity. It's not an optional course. It's not, you know, something they took for fun. They had to do this class. Okay. The definition for this course, the writing program in Santa Cruz, I don't know if many of you know how politically active and how kind of global the school really is. Wanted, you know, the description in the syllabus and on the website for this course is explore the power of language to make meaning. We've talked a lot about that since we've been here. Create identities for the writer, shape communities, and influence readers. These are all great skills for scientists, right? These are all great skills for understanding science, okay? The material they read unexpectedly when they showed up for this class was the IPCC report for the summary for policymakers. Intro textbook chapters for meteorology, oceanography, geology. We read some newspaper articles, some Scientific American articles. We read Nature and Science papers. Okay, these are sometimes heavy material for students. Okay, we covered a whole variety of topics. Each week was a different topic. Some of the main ones: greenhouse effect, aerosols, pollution, precipitation and extreme weather, modeling how we represent the environment with computers, and sea level rise. So that's just some of the topics that we covered in the class. I had an overwhelming amount of female students. There were only 20. It's small student-to-teacher ratios. They wanted us to have more contact hours with our students. Mostly first-year students. I did have one senior, and I will confess he had been in my weather and climate class before and liked the way I taught, and he had waited too long to take his writing requirement, so he took mine. So I have to say that he was kind of an extra plus, because he had already taken my weather and climate class. So just keep that in mind. Okay. So I could spend forever on the educational theory and how we designed the class through the Center for Informal Learning in Schools. But for two of the things that I'd like to just mention is how you design a class like this. I had to teach writing. So a third of the time I spent actually teaching the action of actually writing stuff. How do you write certain types of papers? How do you, what are sentence structures that you need to worry about in these different contexts? But the content was what I was worrying about. How do I get this in there and have it make sense? So for content, this backwards design idea is, how do you get to what you want them to take away? How do you get that nugget of information? So they'd start reading an article that says, very detailed, how CO2 is emitted from cars and industrial processes, it warms the atmosphere, and then how it prevents energy, from going back up to space. But maybe they won't remember that. That's the being familiar with aspect. But maybe they realize that it's important to know that it's only some of the greenhouse gases that do this and that humans really are a part of it. The nugget that I want them to take away, the enduring understanding that if I emailed them 3 years later, I hope they still remember, is that humans can impact the atmosphere and the climate, right? It's not as detailed as CO2 is emitted from cars and industrial processes. They take away that humans can interact with the environment and change it, okay? Now that's just content, but for skills, you'll see on the next slide, I'll talk about some of the specific goals I had, were to give them tools to be able to evaluate scientific material. So the backwards design process for skills and activities were, I had to figure out what I wanted them to be able to do when they left my class. I had to figure out what the evidence for me to let me know that they actually achieved that they went to my desired results, and then actually plan the learning experiences around it. So you figure out what you want, how you can figure out if you got it, and then plan the experiences for the students. Okay? And so this is how you work through the entire course, week by week, class by class, to continually assess as you go along if they're getting what you hope they're getting. Okay? Now, example of one of the activities that was one of their favorites was the ability to evaluate sources of scientific information. This was a huge theme throughout the entire class. It showed up almost every week. So student works cited sections and their criteria for reliability. I'll talk about this specifically later. Like, how do they determine what was an acceptable source for a paper? You have to work cited sections, reference sections in your papers. How did they determine which was appropriate? Wikipedia is not appropriate, okay, for a college paper. So teaching them that there are sources that are better than others, and what are the criteria that you use to determine that, okay? This is all great for science, not just for writing. Okay? And the lessons and experiences that they participated in, one of their favorites was the evaluating sources activity. Okay? And I'll talk about that a little later. The types of papers that are required by the writing program, I didn't have any leeway in this. They had to write these styles in order to complete the course. Personal history, I did make them for my own purposes, you'll see. Describing their life and writing experiences. This allowed me to see where they were coming from, their backgrounds, where they grew up, what kind of life experiences they had. It allowed me to see what kind of influences their community played on their relationship with climate. Okay. Reflective essay. This was their favorite. They had to find a climate change or global environmental change related issue that they had experienced or their family had experienced and had to write about it. Now, we talked about storytelling yesterday and how powerful that can be. Now, this essay probably was the most powerful because it made them realize that they were directly connected to a climate-related issue. It wasn't somebody else. It wasn't another country. It wasn't the Arctic. It was them. It was their family. Okay? So this was the second essay they wrote. So this gave them that positive, emotional connection to the course material. Set the stage for the rest of the course. Okay? They had to do a research project. This was not their favorite. It was a lot of work, but they got to pick the topic. I didn't tell them what to write about. I let them choose. They got to focus on an item of interest that they owned, that they felt was interesting to them. Again, personalizing the information, making connections to climate that they needed to know about. They learned about the other students because they had to do peer review and they had to read each other's papers, and so it was kind of a sneaky way to add in extra topics. They had to write a persuasive letter to a local representative and mail it to them and hope to get a response, and they did. And that ability to persuade or to inform or to ask for information from someone of authority, a political figure, made them feel powerful. It made them feel like they could do something about climate change because they could write about, a lot of people wrote about their research project, which was something about the reflective essay topic, and complain about sea level rise. What are they doing in San Francisco Bay? What are they doing about air pollution in the valley? You know, something that they cared deeply about. And the fun part, the last paper that I got to write was a comparative analysis between a movie and the science that we had talked about. So that was kind of fun. They got to pick things like Twister and The Day After Tomorrow, where they got to rip it apart and say how horrible the science was. And that also made them feel good, because they could identify when the science was good and when the science was bad. That's a great skill for freshmen in college, right, to be able to do. Okay, so I had to battle some misconceptions, and I do this in my classes on the first day. I ask them, make the shape of a raindrop with your hands for me, all of you. Yeah, yes. And Gavin's making what I always see, which is a circle. But not from the students who hadn't taken my weather class. Everyone makes the raindrop shape. Everyone makes a teardrop, okay? I wish everyone did what Gavin did, which is make a sphere, right? And so, what do they bring to that class in the first place? The inaccuracies, the solid understanding, the good foundations. Almost everybody does this, okay? You know, I wish I had more Gavins that would actually make a circle, but they don't. So, I wish. We always get this, and that's a simple experiment to show that they know that they are bringing understanding that's completely not close to reality. And it's like, oh, wow, I didn't even realize that. I just assumed that was right. And it brings to light that that maybe things that they know aren't correct. Okay. So I assessed prior knowledge on the first class. I asked them to free-write a list of issues that they were familiar with, and a whole bunch of stuff came up. The things in colors are things that came up more than 5 times. Okay, so global through local. UCSC had a long-range development plan that was really talked about. It was very political. That came up a bunch, but energy management, organic farming, land use, air pollution, earthquakes. You know, they weren't global climate change related, but they were local issues and things that they were concerned about. Okay. So one of the goals, the general goals for these students, was to provide this understanding or basic understanding of climate issues, give them tools and skills to evaluate that information critically, have them be able to evaluate things like TV and internet sources, and be able to communicate those ideas to other people. Okay, so those were the kind of general goals for the whole class. The specific goals, I wanted to see for me, did they change their relationship with science? Did they gain skills that would help them do those things that I was hoping that they'd be able to do? And did they remember any of the content? Okay. Like global warming, greenhouse gases, sea level rise, and things like that. So we had self-evaluations before and after every paper. We had evaluations at the end of the course. You didn't get a grade on each paper, by the way. You got a grade on your portfolio of work at the end. So there was no grading throughout the semester. 2 minutes. Okay, good. I'm almost done anyway. Okay, so I looked at the wording and coded their papers to look for positive relationships, negative relationships, things that said they didn't like science or that they liked science. I could go into the actual wording that I looked for, but that would take too much time. So we'll start with the negative one. I had this one particular. I didn't like this class. It was too scientific and too hard to understand the material. That's fair. First time I did this, I have to look at the content a little more closely. One of the positive ones, I didn't choose this class based on the topic, but I'm sure glad I did. Not only did I get a handful of scientific knowledge, but I learned how to write. Okay, I become more informed about what is going on in the environment I lived in, gained in knowledge that I can use in my future college career. Okay. For the ending with positive relationships, there were 10 distinct students who mentioned those types of relationships, and there were 3 that either didn't like the fact that there was too difficult scientific material or just didn't really like writing. So what are you going to do? For skills, this is an example. One of the skills assessments was looking at their evaluations of themselves and what kind of skills they learned. They loved this evaluation of internet sources activity where they had to provide reasons why they thought was a source was good or not. And it was surprising how the number of students kind of agreed with each other on credited websites from government or educational institutions, you know, and let's see, accurate concepts, not biased. These are their own words. I didn't tell them to look for these things. They came up with these categories on their own. Unreliable sources have no author, they're biased, they're unprofessional, there's typos. They were able to determine these things by themselves, okay? The content assessment, I gave them questions from my weather and climate class from their midterm. to see if they could give me similar answers, you know, to those things. Oh, I'm done. Okay. See, look at that. Everyone should do that. So some of the questions, there's only one more slide. I had them define what albedo was and what the contributor was. I had them explain why sea level happened. And 19 was the highest score I got on this. To be fair, this was from the science class. On average, the students did fairly well. There was about a 60% accuracy. So the lessons learned, students left the class more comfortable with scientific information after looking at their self-evaluations. The material was too advanced in some cases, so for the future classes at UH, I'm going to be revising the reading list. The most successful aspect were the skills, evaluating scientific material from different media sources. They did learn general concepts and some specific facts. Their favorite class activity, though, was the end of semester climate change Jeopardy activity. It was super fun. Man, they knew those answers because they studied for it. They wanted to win the prize, you know. I will be administering the content tests at the beginning, middle, and end now to see how it changes over time. I didn't do that for this class, but I will in the future. Okay. For the future courses, I plan to do surveys after the class ends at standard intervals to see how long the content retention stays. I did email the students from this class about a year afterwards. I didn't get enough respondents for it to be meaningful, but some of them still did retain that information. So, thank you.